Hello everyone. This is fourth, let me see if this is the fourth or fifth video. 4, 1, 2, 3, 4. This is the fifth video on chapter 9. And those of you who have been following, we did stop on slide number 33, where this company is checking or testing to see if there is underfilling or overfilling taking place filling up the tubes, the toothpaste tubes, and the mean average was the sample mean is 6.1 ounces sample mean, and the average supposed to be 6 ounce, and a standard deviation 0.2 in the sample of 30 was taken. So this is the example of the equal not equal. We first develop the hypotheses. That's step number 1. The second step is specify the level of significance, which is 0.03. Half of the alpha would be 0.015. Step number 3, calculate test statistic, which is Z. We find a Z. Now we can either use just the Z to compare to Z of the given alpha, or we use the Z to go and find the area. This method is called p-value. So we find the area, which is 0.9967 from the Z table. Excuse me. And then this is two-tail hypothesis testing. This is a two-tail hypothesis testing. Whatever p-value that we measure is going to be p-value for one side. If 2.74, which is, let's say that this is 1, 2, and let's say that this is, for example, 3, 2.74 is going to be somewhere right there. 2.74. For 2.74 from here all the way, from here to here, the area is 0.9969. If we take that away from 1, that's going to give us the p-value. But if we want to compare it against the alpha, the total value of alpha, because that's only p-value for one side, we have to multiply by 2. 2 times 1 minus 0.9969, that will be 0.0062. Compare this against the value of alpha, which is 0.03. This is smaller than this, then we have to reject the H0. So they're not going to be able to reach the goal of 6. That means they have to stop the operation. Probably underfilling, overfilling is taking place. So in this case, we would say overfilling is taking place. Overfilling is going to make the company to lose money. Underfilling is going to make the company liable towards their customers. So that's why that they have to go ahead and make sure that the average is going to be exactly equal. So decide whether they're going to fix the problem or they don't want to go ahead and fix the problem. That's why we call it decision making. Now there is one more approach in testing the hypotheses, and that is the use of the margin of error, the confidence interval that we learned in chapter 8. So we can go ahead and say 6.1, which is our sample mean. Another method is this. We go ahead and, oh, this marker doesn't come off that easily, so forget about this one. I don't have any on the other side. If you remember, x bar plus or minus z sub alpha over 2 sigma over square root of n. In this case, this is another method which is not that popular as the other two, the p-value and critical value. 6.1 plus or minus find excuse me, find the margin of error, add and subtract it to this. We're going to have a range. If the hypothesized average, which is 6, the mu, if that range includes that 6, then we accept the H0. But if it doesn't include 6, then we have to reject. Now, by the way, any of these methods that you use, if they lead you to reject the H0, to reject the null hypotheses, the other two methods must lead you to the same result. If they are not consistent, then you have done something wrong. So all three must lead to the same result. Z sub alpha over 2 for, that was 93, alpha is equal to 0.03, so half of it is going to be 0.015. So we have to go and look, 1 minus 0.015 so we have to look, 1 minus 0.015. 1 minus 0.015 would be 0.985. We have to go ahead and locate 0.985 and then read the corresponding value of the z for that. 0.985 the value is 2.17. So this is 0.985. I don't know if this is clear enough. 0.985. Then the value is 2.17 plus or minus 2.17. Sigma is 0.2. Square root of 30. Let me see if this is, the value is 6.1 plus or minus 0.07924. Look, if we add and subtract this to 6.1, if we have that 6 within that range, so the range would be 6.0 2076 to, this is the lowest, to 6.0 0.17924. So you see that 6 is not within the range. If 6 was within the range, then we would accept. But now in this case we have to reject the H0. This is on slide number 38. Now let's work on problems 9 and 13. Let's work on problems number 9 and 13. Let's see. Okay, for 11th edition users, page 367. For 12th edition users, page 402. For 13th edition users, page 407. Here is problem number 9. So chapter 9, problem number 9. This is given H0 mu greater than or equal to 20, mu less than 20. This is one tail, upper tail. I'm sorry, one tail, lower tail. One tail, lower tail. I want you guys to pay attention to this here. If you guys remember back in chapter 6, I said that we have three cases: x greater than or equal, x less than or equal, x in between. You guys remember that? In chapter 6, this is the one tail, or this is the case of 1 minus. This is where we're reading the value off of the, to find the probability, the value off of the z-table. This is where we found the value in both sides for two z's, and then find both areas and subtract the smaller one from the larger one. So this actually was when we were doing this and find the area in here. But in this case of hypothesis testing, this is opposite to this. This is the lower tail. All right, so I want you guys to make sure that you don't get confused over that. So anyway, this is given for problem number 9. And then problem number 9, a sample of 50 provided a sample mean of 19.4. So n is equal to 50, x bar is equal to 19.4, population standard deviation is 2, sigma is equal to 2. Part A, compute the value of test statistic. Z is equal to x bar minus mu sub 0 divided by sigma over square root of n x bar 19.4 minus 20 divided by 2 over square root of 50. So the answer is z is equal to negative 2.12. Part B, what is the p-value? Now that this is a negative value, we go to z table for negative value. If you guys remember, for lower tail, negative value, we just go there and read the area off of the table. Negative 2.12, negative 2.12, the area is 0.017. So p-value is p-value equal 0.017. That's the p-value. Part C, using alpha equal to 0.05, what is your conclusion? So this is for part B. This right here was for part A. This is for part A, part B. For part C, they say alpha equal to 0.05. What is your conclusion? Our p-value is 0.017. So we say reject H0 because p-value, which is 0.017, is less than alpha, which is 0.05. For part D, what is the rejection rule using the critical value? And what is your conclusion? So now for part D, rejection rule for critical value is reject if z-calc is greater than or equal to z of the alpha. This is for positive values. Negative z-calc less than or equal to negative z of the alpha. Okay? Now we have to go ahead and find what the z of the alpha is. Alpha is 0.05, but because this is our z that we calculated is negative, and that is negative 2.12, so z-calc right here is negative 2.12. Then we compare it against the negative z of the alpha. So we assume that since this is on the negative side, on the left-hand side, then we have to compare it against the value of the alpha on the same side. Let me just go ahead and erase this to show it to you here on the curve. So this right here is going to be 0.05. This is going to be our alpha. Okay? Now we have to go ahead and find out what the z would be for this side. If you go to the z table, locate 0.05, Again, for 0.05, we cannot locate the exact value. For 0.05, this is what we have. Those two values, 0.0505, 0.0495, I think. Yeah, 0.0495. Those two values, 0.0505, 0.0495. So we approximate between the two. The z of the alpha, the z of the negative alpha is going to be negative 1.645. Because this is smaller than this, then we reject. We say reject H0. Because our z value calculated is less than the z of the given alpha. Now, problem number 13. The hypothesis number 13, this is given less than equal to H0, HA, mu is less than equal to 50, and mu is greater than 50. Part A, a sample of 60, that is equal to 60, is used, and the population standard deviation is 8. Sigma is equal to 8. Use the critical value approach to state your conclusion for each of the following sample results. Use alpha equal to 0.05. So alpha equal to 0.05 for part A, they say x bar equal to 52.5, 52.5. Now z is equal to 52.5 minus 50 divided by sigma, which is 8, over square root of n, which is 60. So our z is going to be equal to 2.42. 2.42. Now we just go ahead and use the critical value approach to compare it against z of the alpha. So we know that z calc is going to be, this is positive, greater than equal to, this is rejection rule, z of the alpha. So our z calc is 2.42, which is greater than z of the alpha for 0.05 is 1.645. Therefore, we have to go ahead and reject H0. Why? Because our calculated z is greater than z of the given alpha. For part B, that's pretty much the same as part A. You just put in 51 instead of x bar. For part C is pretty much the same. All you have to do is just replace this with 51.8. And then for part, let's see, they only have 3 ports. Okay, so I'll go ahead and do, I only have 2 minutes left. I go ahead and do part B real quick. So this was for part A. Now let's go ahead and do part B. For part B, they have x bar equal to 51 This is going to be 51, and this is going to be 0.97, and z-calc for 0.97 is, this is the z calculated. So z-calc is 0.97, which is less than z of the alpha, which is 1.645. So in this case, do not reject H0, because our z-calc is not greater than z of the alpha. Thank you for this part. I'll get back to you later. Bye-bye.